was a 5-mark question on a provincial exam a couple of years ago. It actually had some controversy. It was on a non-calculator part because you don't have a graphing calculator on your exam. So the questions that we were doing to start, where we used Desmos or a graphing calculator, that can't be asked on the exam. So then how could a question like what we've just been doing be asked on a final exam, and what would it look like? And then we'll talk about some of the controversy of this example as a result. Okay? A box is in the shape of a rectangular prism, so I don't know if you're getting good at drawing three-dimensional stuff. With side lengths of x, x plus 2, and x plus 10. There we go. Write a function volume to express the volume of the box. So volume would be length times width times height. So if you wrote x times x plus 2 times x plus 10, that was the first mark in this 5-mark question. Then it said, find all possible values of x, given that the volume of the box is 96 centimeters cubed. So if we know the volume, this would be 96 x, x plus 2, and x plus 10. And now we had to solve for x. Now, since it was a non-calculator question, most students just started guessing and checking at this time, which I forget if the exam only gave them 2 out of 5 if they guessed and checked, or 3 out of 5 if they guessed and checked and got it right. So that's where the controversy was. Because being a non-calculator question, you kind of know that the number has to be nice. So it seemed like the best strategy at this place. Okay? What the exam was looking for is that if you want to find all possible values, the only way you can find all of them is if you do a solution that's algebraic. Because when you do the algebra, the answers that you get are the answers that are possible. Well, how do we solve a question like this? It's already factored, but already factored is only useful when one side is equal to 0. So in this question, what was actually expected of the students is that they multiply this out. I'll multiply those two first. And then I'll multiply the next two together. And I'll get x cubed outside 10x squared plus 2x squared plus 12x squared. And the last one's plus 20x. And now I can move it over and solve. And actually the students that used guess and check actually had an advantage if they also wanted to do it algebraically. Okay? Quick check. If you plug in 1, is 1 times 3 times 11 96? No. So what number would you probably try after 1? 2. You tried in 2. 2 times 4 is 8. 8 times 12? 96. So it was not very hard to find out that x equals 2 works. Also, because it's a real-life word problem, could x ever be negative? No. So when we're going to do the synthetic division here to see what is going to make this work, okay, and here I would write let p of x equal this. I'm going to set up my synthetic division. 1, 12, 20, and 96. Negative 96. If x equals 2 is an answer, then x minus 2 is a factor, which would mean I need a positive 2 out in front here. I bring my 1 down. Multiply, add, multiply, add, multiply, and sure enough, I get a remainder of 0. So I can write my division statement that p of x is equal to x minus 2 x squared plus 14x plus 48. Because algebraically, if we can factor this even further, there might be more than one right answer. And this does factor nice to be x plus 8 and x plus 6. And we actually get 3 answers that would work. X equals 2, x equals -8, and x equals -6. What's the problem with -8 and -6?
X can't be negative.
In real life, these don't make sense. So in actuality, the only answer is x equals 2. So I know this is the answer. What do I have to do? It's a word problem. What did they actually ask me to say? Find all possible values of x, given that the volume of the box is 96. State the dimensions of the box. So if x is 2, it would be 2 centimeters by 4 centimeters by 12 centimeters. And if we don't include the centimeters, we would lose an E5 marks for getting units. If you're doing a word problem and there's units, your answer needs units as well. So we solved for x, we solved for it algebraically, and we got the dimensions. That would give us 5 out of 5. If you didn't solve it algebraically, I think they only gave 2 out of 5, and teachers were mad. Because students got the right answer. Even this, at a 96, possible factors of 96 include like 96 and 1. Do you think you could plug in 96 using a non-calculator part? No. So there was a little bit of controversy on this question, but I just wanted to show what it could look like on an exam. And I'm going to, on your test is going to be non-graphing calculator. You don't need a graphing calculator, but you would still be expected to do the setup. Without finding the answers, could you set up the equation? Could you draw the graph? You can draw the graph without your calculator. So you can see what the domain is without your calculator. And we could get a question just like the one we just did. We could get one like this with a calculator, and you would have to solve it algebraically. I think I put one, you can put a star beside this on page 56. I think I have one like this on your test with different numbers. Sometimes it gets really tricky because, I mean, this one factored. Sometimes you have to use a quadratic formula for this to check if it works. So there's some different possibilities with that. Okay.